Hey guys, this is just a review of our Unit 1 study session that we did in class this week. So if you missed something or you just need to take another watch, I'm just going to go quickly through what we reviewed in class. So looking at our first problem here, we have a polygon, and a polygon is a shape that's made up of other shapes. So I can see here that this one is made up of a rectangle as well as a triangle. So in order to find the area of this shape, I'm going to find the area of the triangle and the rectangle and then add those together. So the area of a rectangle is base times height. The area of a triangle is half base times height because it's half of a rectangle. Okay, so what I'm going to do is I'm just going to go through and put in those dimensions so that I can get ready to solve them. For my rectangle, I'm looking for my base. And if I can see this part here is the base, and I know that the top part is the exact same. So this measurement 15 is going to be our base, and then our height here, 17. Okay, and before I do any of that multiplication, I'm going to go ahead and get the dimensions for my triangle. So looking for my base, as you can see, it's part of this big long piece. So what I need to do in order to find this part is I know I have 15 up here, and this total is 25. So if I can do 25 minus 15, I'll have what's left over here. So 25 minus 15 is 10. And then we'll look for our height, which is the bottom of the shape to the very top of the shape. And I can see that matches this here, so 17. Okay. And then we'll just go ahead and do our computation here. So we have 15 times 17. 7 times 5 is 35. Carry the 3. 3 times 1 is 7, plus 3 is 10. We'll move to our next place value. 1 times 5 is 5. 1 times 1 is 1. And then we'll add these partial products together. So 5, 5, and 2. So that means that my area for this rectangle is 255. Now let's do our triangle. So I know 17 tens. If I were to count by tens 17 times, I would end up with 170. And then I'm going to take half of that to figure out the area of the triangle. So 170 divided by 2, or cutting it in half, right? 2 goes into 17 8 times. Not evenly, we're at 16 with 1 remaining. Bring down your next place value. 2 goes into 10 5 times evenly. Okay, so then that means this guy is worth 85. So I'm almost done. All I need to do now is add my two areas together. So we'll do 255 plus 85. 5 plus 5 is 10. 8 plus 5 is 13 plus 1 is 14. And 2 plus 1 is 3. We'll come out with an area of 340 feet squared. Okay. Now, looking at our second problem here, this one is with order of operations, and we're going to do some exponents here. So we have an algebraic expression and some values that we're going to substitute in. So anywhere I see a D, I'll put a 4, E 2, and F 5, and then we'll solve using order of operations. So I have 4. There's a D there, so I'm going to put 4 plus 10. Then I have a space for E, which is 2. That exponent is with that variable, so we'll keep that together, divided by f, which I know is 5 minus 2. So now we're just going to go through the order of operations. The first thing I see is groupings, so I'm going to look for groupings. I see some parentheses here that need to be simplified, so I'll go ahead and rewrite my problem. Okay. And I know that 4 to the third is the same as 4 times 4 times 4, and 2 squared is the same as 2 times 2. So I'm just going to go ahead and simplify these and put their answers in those parentheses. Okay, so 2 times 2 is 4. 4 times 4 is 16, and 16 times 4 is 64. Okay, so I've done my groupings. Now I'm going to check for exponents. I don't see any exponents in this expression, so I'm going to go ahead and move to multiplication. I do see some multiplication right here. So I'm going to go ahead and multiply those out. 4 times 64. Okay, we have 16, carry the 1, 24 times, sorry, 1 times, 6 times 4 is 24 plus 1 is 25. So we have 256 plus 10 times 4, which is 40. And then we're going to continue bringing down the rest of our expression. Okay, so I've done my multiplication. Now I'm looking for division, and I see some right here. 40 divided by 5 is 8. Bring down the rest of our expression. Okay, now I'm going to look for addition or subtraction going left to right. I see I have addition here. So 256 plus 8 would be 264 minus 2. Now we can go ahead and do our subtraction. Ta-da! And we have done our order of operations. Looking at number 3 here. Excuse me. Ooh, I've been talking on meats all day. My throat's a little dry here. Okay, so we have area equals base times height because we have a parallelogram. So we're going to be looking for our base of the shape, which is 15.5, times our height, which is from the very bottom of the shape to the very top of the shape. So I can see that that kind of matches right here. So my height is 8. Then I can just multiply to find my answer. Woohoo! Super doable for these parallelograms. Okay, now this one is a little more involved because we are looking at a 3D figure. So what I'm going to do is I'm going to draw a net, starting with using my base for those areas. So I have kind of a skinny rectangle on the base. If I were to flop them open right here on the sides, I would have 2 large rectangles opened up. And then again here, if I would open up right here and right here, I would have some skinnier rectangles. Okay. And then the final part that I need to have is this top piece, which is the same size here as this middle one. So I'm going to go ahead and I'm going to put it up here. So if I were to close everything up, that would be what it would look like. I'm going to use some color coding here to help me with my measurements. So anything that's green, I know will be worth 5 inches. Okay, and that's all those things that are the same on my 3D figure. Okay, so all of these side lines right here would be worth 5. Okay, because they're all touching together. Okay, then we have our blue spot here that's worth 2. So any of these little 2 guys. Okay, and then finally, the ones that we're left with are our 7 inches. Okay, so all these are going to be worth 7. Okay, so now I can just go ahead and multiply. 7 times 2 is 14, which is the same here. 7 times 5 is 35. And then 2 times 5, we know is 10. So now that we have all those little areas, we're going to go ahead and add those up to find a total surface area. So I'm just going to put some of these smaller numbers together. So 14 and 14 is 28, 35 and 35 is 70, and 10 and 10 is 20. So we have 28, 70, and 20. We're going to add those together to have a surface area of 118 inches squared. Ta-da! All right, and this one, really what we're looking for here is what is my base number? What's the number that I'm repeating? And what's my exponent? How many times is that number being repeated to be multiplied? Okay, so I see that the number I'm going to be repeating here, my base number is 4. So I'm going to repeat that 6 times. Okay. Now, the lovely thing about this lesson is we've already figured out what 4 to the third is in one of our previous problems. And usually when we have a long string of exponent problems like this, what we want to do is we want to kind of chunk it into easier groups. So I know that 4 times 4 is 16 and 16 times 4 is 64. So really all I have to do here is 64 times 64 to find that answer, which I'm just going to go ahead for the sake of time here. Okay, so we could do a multi-digit problem here, but this is what we would end up with. Okay. Right, let's see. Let's double check 4 times 6. Oh, so sorry. Oh, it's the end of the day. Okay, 6 times 4 would be 24. Carry the 2. 6 times 6 is 36 plus 2 is 38. Okay, 6, 9, 10. Oh, I got a 3 there. I must have done something wrong here. Oh, that's a 30. 38, sorry. So that should be a 4. Okay. Now looking at number 6, this one is just practicing algebraic expressions where I am substituting in a variable, a known variable, into an expression to solve. So we have anywhere I see an m, I'll put a 4 here. So 4 to the third plus 75. Lovely, we have done 4 to the third before, so it's the same as 4 times 4 times 4, right? Plus 75. I know that that's 64 plus 75. 4 plus 5 is 9. 6 plus 7 is 13. Ooh, so super doable. Okay, our least common multiple I like to think of as either skip counting or we can use prime factorization. For this one, because these numbers are a little bit more doable to count by, we're just going to list our multiples. So we'll do 20, 40, 60, 80, 120, 120. So, okay, we'll just go a little bit out there and then we'll start counting by 35s. 70, 105, 140, 175, and we'll stop there because I can clearly see here the first number that they're going to meet, that the smallest that they share in common, is 140. Okay. Now looking for our greatest common factor, that's where we're using factor pairs. We're looking to see what two numbers can multiply together to make this product. And then we'll look at those factor pairs and see which one do they all have in common. So I know that this could be 2 times 7, 5 times 7, 7 times 7. So I can see here they all share a 1, but they also share a 7. And out of the two numbers, which is larger? 7. So my greatest common factor is 7. And then finally, looking at our last problem here, we have a triangle with some dimensions, and we're going to use our formula for area. Okay, so we're just going to pop our dimensions in there. Okay, I see my base here, 22. And my height from the bottom of the shape to the very top of the shape is 15. Now I can just go ahead and multiply my numbers here. So I have 22 times 15. 5 times 2 is 10. 5 times 2 is 10 plus 1 is 11. Move to your next place value. 1 times 2 is 2. 1 times 2 is 2. Add those partial products together. And we'll find that we have area equals half of 330. So our last step, what we're going to do is take 330 and divide that in half. Okay, so 2 goes into 13 6 times, making 12, not evenly. And 2 goes into 10 5 times evenly. So we know that our area is 165 centimeters squared. Hooray! All right, guys, I hope that's helpful for you in order to prepare for our test next session. You guys are going to do great. If you have any questions, please let me know.